Lesson 5.7, Rational Exponents. We're going to look at rational exponents here, and a couple lessons ago I kind of led into rational or fractional exponents, so we'll kind of tie that in. These first few examples will be a little bit of review of what I was kind of leading you into back in, I think it was 5.6. But if you remember, we'll just review a little bit. Okay, if I have something, the square root of something, okay, whatever's underneath there, that would be that to the 1/2 power, because the index on square root is 2. If I have cubed root of something, that would be whatever's under there to the 1/3 power. Okay, fourth root would be whatever's under there to the 1/4 power, and you could keep going there. So keep that in mind as we go through these first few. Okay, so in the first part here, we're going to write each expression in radical form. So notice that these are rational exponents or fractional exponents. Remember, fractional, rational means the same thing. Ratio, fraction are the same. So a to the 1/6 power just means it would be the 6th root of a, and m to the 1/2 would be the square root of m. We usually don't write the index of 2, so we would just write it like that. But you could put the index of 2 on there. Okay, now we're going to go the other way. We're going to go from radical form to exponential form, meaning write it with a fractional exponent. So this, if you have the 5th root of b, now we're just going backwards, would be b to the 1/5 power. Square root of w would mean w to the 1/2 power, because again the index there is 2. Okay, so some real basic stuff of converting from one to the other. Alright, evaluating expressions with rational exponents, and we're also going to look at some that have negative exponents. Okay, we're going to remember how to do negative exponents. I'll show you a few different ways that you can deal with those. So anytime you see a negative exponent, okay, this is like over 1. Whenever we have a negative exponent, we're going to want to make exponents positive. Okay, whether it's with the base being a number or a variable, doesn't matter. So if you do this to make the exponent positive, okay, because the exponent is negative 1/2 on the 49, you move the base and the exponent to the opposite part of the fraction. Now, notice I put it over 1 so that we really have a fraction. That means I'm going to move it down and make it 49 to the 1/2 power on the bottom. If I move this down, okay, I'm getting rid of that 49 to the negative 1/2. I have a 1 on top. So that's kind of the first step. Okay, now what this really means is you have a 1 on top. 49 to the 1/2 power is really the square root of 49. And notice 49 is a perfect square, so this really means 1 on top. The square root of 49 is 7, so this would be 1/7. So 49 to the negative 1/2 power is 1/7. Okay, if you go to the next one, it's 32 to the 2/5 power. Okay, now the bottom number here, or the 5, is the root. So I want the 5th root of this base, 32. Okay, now when the top number is something other than a 1, then you want to take and raise it to that power. So that 2 becomes up there. So I really want the bottom number of the fractional exponent, or the rational exponent, the 5th root of 32. Okay, we're going to do that first. The 5th root of 32 is 2. So I really have 2 squared, which is equal to 4. So 32 to the 2/5 is 4. Another way you could do that is you could take the 5th root of 32 and then put the square underneath the radical, or the top number. Okay, 32 squared is 1024, and the 5th root of 1024 If you find the root button on your calculator on the TI 83s or 84s, that's under the math menu, and you want the one that's got the X in there and put the fifth root. But the fifth root of 1024 is 4. So you get the same answer whether you do it the way I did on top there or the way I did on the bottom. It works either way. Okay, simplify expressions. Simplifying expressions with rational exponents. Okay, I want to review a problem here first. Let's go back to stuff you did when the exponents weren't rational. If you had x squared times x to the fifth, the product rule says we add exponents. So it was x to the 2 plus 5 power or x to the 7th. Okay, it's no different here on this first example where we have y to the 1/7 times y to the 4/7. Okay, you're doing the product, so I am going to take 1/7 plus 4/7, which is actually equal to y to the 5/7 power. We already have a common denominator, we're just adding 1/7 and 4/7. Okay? When the problem starts out with exponents that are fractions, you don't have to put in radical form. Now, this in radical form would be the same as the 7th root, because that's the bottom number in the fraction, of y to the 5th. These two things right here say the same. Now, if the problem starts out with exponents that are fractions, you can leave your answer that way. And that's how, when you check your answers on your homework problems, that's how they'll leave them. Okay, it is okay to write it this way because that's really what it does mean. But if it starts out with rational exponents, you write it with rational exponents, usually your answer. If the problem started out with radicals in root form, you probably want your answer in root form. Okay, now this is x to the negative 2/3. I'm going to put that over 1, kind of like I did with the previous example up there where we had a negative exponent. Okay, we are going to move this to the opposite part of the fraction and make the exponent positive. Okay, so there's my first step. And when we move that x to the negative 2/3 down to make it x to the 2/3, we get a 1 on top. Okay, so there's what I have. Now, think about this. We cannot leave our answer that way, because this really means, this right here really is the same as 1 over the cubed root of x squared. We cannot, if you remember from simplifying radicals, you cannot have the root or radical in the denominator of a fraction. We need to rationalize. Now, I'm not going to change it to root form. I'm just telling you that's why we have to adjust this. Anything that's a fractional exponent down there is root form. So we want to rationalize the denominator. And here's how you do it with fractional exponents. I want to multiply this by x to some power so that when I use my product rule and add the exponent, this exponent plus the 2/3, I get a whole number. Okay, so if you notice, I am going to do x to the 1/3, because now on the bottom I will have x to the 3/3, or which will be x to the 1st on the bottom. And I've gotten rid of the fractional exponent. Okay, because when I do my product rule there, now if you multiply the bottom by x to the 1/3, you have to multiply the top by x to the 1/3. And 1 times x to the 1/3 is x to the 1/3. Okay, and so my answer would be this, or you could just do x to the 1/3 over x. You can have fractional exponents or radicals on top, not on the bottom. Okay, now we're going to get to some more difficult things, and I think the order that I do these in may be a little different than the order they are in your notes, so just, or the letters may be different, so just follow along and make sure you're writing down the things on the correct problem there. Okay, simplifying radical expressions. Simplify each expression. Please pay attention to this, okay? To make things easier, always write any numbers you're dealing with under the roots, okay, the smallest base possible. What I mean by that is, for instance, if I had the number 25, I could write that as 5 squared. If I had the number 4, I could write that as 2 squared. if I had the number 16, I could write that, you don't want to write it as 4 squared. I agree it's 4 squared, but you actually can write that 16 as 2 to the 4th power, 2 being a smaller base than 4. So you always want to write things in the smallest base possible. This is going to help you simplify things. Okay, so let's look at this first one here, which is the 6th root of 16 over the cubed root of 2. Okay, the 6th root of 16 over the cubed root of 2. I am going to change these as my first step to fractional exponents. So I'm going to have 16, 6th root means 1/6 power. So I'm going to write the top as 16 to the 1/6. On the bottom, I'm going to write it as 2 to the 1/3 power. Okay, so I'm writing the radicals as fractional exponents, which we did earlier in the lesson. Now, what I want you to notice is on the top right here, I have 16. I can write that with a smaller base, meaning 16, it can be written as 4 squared, but 4 is not the smallest base. The smallest base, okay, would be 2 to the 4th power, because 16 is 2 to the 4th. Now, that 16 was to the 1/6 power, so I have to raise my 2 to the 4th to the 1/6 power. Okay, and then on the bottom, I can't write it with a smaller base than 2, so I still have my 2 to the 1/3. Okay, now, right here on top, you have a power to an outside power. Power to a power, just like with this, if I had x squared to the 3rd, the rule is power to power, you multiply exponents. Well, that's what we're going to do right here. So we're going to multiply those exponents. So I get 2 to the 4/6 power. Remember, 4 times 1/6 is 4 over 1 times 1 over 6, or 4/6, okay, over 2 to the 1/3. Now, this can be reduced. 4/6 is the same as 2 to the 2/3 power over 2 to the 1/3 power. Okay, I'm just reducing the 4/6 there that's up in the exponent. That's 2/3. So now, when these bases are the same, I'm dividing. I subtract exponents top to bottom. Okay, so that would be 2 to the 2/3 minus 1/3. And notice I already have a common denominator there. So that 2/3 minus 1/3, because I'm dividing, that's what the rule says, that would be 2 to the 1/3 power. Now, that is simplified, except for this original problem right here was written with roots. So we want to go back and we want to write this as a radical. Well, what does 2 to the 1/3 power mean? It means the cubed root of 2 to the 1st power, or the cubed root of 2. So we want to write the answer this way as opposed to 2 to the 1/3, because our problem started out in radical form. Okay, let's look at the next one. We have the 4th root, or the 6th root of 4x to the 4th. So here's what we're going to do. We're going to write it as 4x to the 4th to the 1/6 power. Okay, so I am going to do, and now I want to write 4 as a smaller base. That's the same as 2 squared. So inside there, here's what I have. It's to the 1/6 power. Okay, so now I'm going to multiply power to a power exponents. So I'm going to have 2 to the 2/6 power, x to the 4 times 1/6, or 4/6 power. Okay, well, that's 2 to the 1/3 times x to the 2/3 power. Okay, which is, notice these are the same now, so we're talking about cubed root of 2 to the 1st power, top number is the exponent there, times x squared. Top number is that, but they're both cube roots because the bottom number is a 3. So let's clean this up a little bit and write it as the cubed root of 2x squared. And that would be as simplified as you can go on that particular problem.